In 1686, Isaac Newton created the theory that answered the questions of motion.
His theory consisted of 3 laws that all motion follows.
Newton's first law stated, an object at rest remains at rest, and an object in motion remains in motion at a constant velocity unless acted on by an unbalanced force.
This means that an object that isn't moving won't move unless an unbalanced force acts upon it.
If there's a net force of 0 newtons, no motion will occur until there is an unbalanced force.
In other words, objects don't randomly start moving.
Likewise, objects that are in motion will remain so at a constant speed until an unbalanced force acts upon it.
An object in motion will continue with the same velocity until an unbalanced force affects it. It will not speed up, slow down, stop, start, or change direction without an unbalanced force.
Objects will not deviate from their current velocity illogically.
There must be the presence of an unbalanced force to accelerate an object.
Take this egg. Sitting on this rock, the force of gravity is pulling down, and the rock pushing up are equal and opposite. Therefore, the net force is 0 newtons, and the egg is at rest.
Apply an unbalanced force, such as throwing the egg, and the egg is set in motion. It will continue to move at a constant speed in a straight line until there is unbalanced force. Logically, we know that the egg does not behave this way. It plummets to the ground and stops moving.
By scientific deduction, we know that this means an unbalanced force must be acting upon the egg.
These 2 forces are friction and gravity.
A force that opposes motion will gradually slow down an object as the molecules along the surface of each object rub against each other.
Gravity also is acting upon the egg. Gravity is the reason the egg is pulled downward to the earth.
Thus, the unbalanced forces that cause the change in egg velocity are friction and gravity.
Commonly, Newton's first law is referred to as the law of inertia.
Inertia is a measure of the mass in an object, as well as how much it will resist change in motion. Inertia is the reason an object will stay at rest or at constant motion until a force causes change.
The more mass an object has, the more inertia it will have, and it will be harder to accelerate.
His second law, Newton stated that the acceleration of an object depended on the mass of the object and the amount of force applied.
Newton's second law illustrates the relationship between acceleration and force.
He determined that acceleration depends on 2 factors, mass of the object and magnitude of the force applied.
He also acknowledged that acceleration is in the same direction as force applied, and that when more force is applied to an object, there will be a greater acceleration. An example of this law in motion is chickens running at different speeds.
Using Newton's law, it is determined that due to the fact that the 2 domestic birds are applying different amounts of force,
the chicken that appears to be traveling at a faster rate is applying more force, so it has a greater acceleration. Newton also observed that the more mass an object has, the less acceleration occurs.
Likewise, a lesser mass translates to a greater acceleration. Less force is needed to have the same acceleration in an object with less mass.
A common example of this is the application of gravity.
Gravity will affect an object with a larger mass more, meaning there will be a larger force acting on it. However, it will accelerate at the same rate as an object with a lesser mass because an increased mass also means increased inertia.
An example of this is when 2 objects of varying masses are dropped from the same height.
They should fall at the same rate, but this is not illustrated perfectly here due to the factor of air resistance, a type of friction, acting differently upon the 2 objects.
Newton concluded that there's a direct correlation between force, mass, and acceleration. He figured that he was able to mathematically calculate force using the formula force equals mass times acceleration, or to calculate acceleration by using the formula acceleration equals force divided by mass.
In his third law, Newton stated that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first.
In other words, when one object applies force, another applies the same strength force, but in the opposite direction.
Law, there are 2 classified types of motion: action and reaction.
These types work in pairs, and there is never a single force acting on an object. For every action, there is a reaction. However, these pairs do not both occur on the same object at all times. If they did, the net force would always be 0.
Take this example of a roosting chicken. Gravity is pulling down on the chicken, but the roost is applying force of an equal strength that is also opposite.
As a result, the net force is 0 newtons and the chicken remains at rest.
But then how does a chicken gain forward motion?
The chicken pushes its feet and applies a force in a backward motion to the ground. The ground's opposite motion pushes forward. The chicken moves forward.
You cannot always see both the action and the reaction. This is why when the chicken pushes down on the earth does not move significantly.
The Earth's mass is far greater than that of the poultry, so it has larger inertia and the acceleration is so small it goes undetected by us.
It's true of falling objects. You cannot detect the pulling up of the Earth.
The forces are equal, but the masses are vastly different, so the acceleration is very different in size. Newton's laws apply to all motion. They define the parameters of motion and can help paint an understanding of motion.